Hi, good afternoon, everybody. My name is Joana Pinto. I'm here in Barcelona at Zigurat's headquarters, and today we have another masterclass, which is brought by Mirbek Bekboliev, and we've invited Mirbek to present this masterclass. This is a masterclass that is connected to one of our master degrees. It's the Global BIM Management Master Program. It's a program of 1 year, as all our master degrees. And basically, well, it talks about BIM management, and it teaches you how to create a project from scratch using BIM methodology. And we have Mirbek is a known contact of our director, David Delgado. Mirbek, he has a lot of experience in passive house design, and he has joined Building is Smart in Germany. He's based in Germany, so that's how we met him. And we've invited him to come and present a project about passive house design, and Mirbek will explain to us what the project was, but mainly he'll focus on the issues, the barriers they've encountered, and how you can overcome those. So it's a practical case. We try to bring practical projects and case studies to our students and to all of you out there, so that you can see how to apply the knowledge in practice also. So I'll leave you with Mirbek for the presentation of the case, and then at the end we'll have 15 minutes for questions. And you can, if you want, you can start writing in the question box that we have in our platform. You can start writing down the questions, and I'll connect after the presentation to moderate and help you go through them and help Mirbek go through them. So just feel free to use the chat and the questions box, and I'll be here, okay? So Mirbek, he won't connect his webcam, just for the sake of the good connection. Most important thing is for you to be able to see the presentation. And I'll disconnect my webcam, and I'll leave you with the presentation. So Mirbek, thank you very much for accepting our invitation. I'll leave you now to present your case, okay? See you later, everybody.
Hello, everybody. Before I will start, I will simply say one word about openBIM. It's not difficult to work with different software vendors. It's important that we work with open standards, and it's vital to work with stakeholders as an integrated process. So you collaborate at the same level, at the same time, with all stakeholders from the very beginning. That's very important. Hello, everybody. It was a small statement. My name is Mirbek Bekboliev. I'm a technical coordinator of working groups and standards in Building Smart Germany. I'm also working I'm supporting Building Smart International in Building Room with standardization projects that also coming from our part from Germany, and coordinating that kind of activities, mirroring them from international to national level. So today I would like to introduce one small project, very small, but it was really interesting, very old project. It's based on our research project from my master's degree. I conducted this project for Middle East Technical University together with two stakeholders, two partners, and with whom I had a chance to work with. I will go through the points. It's a small, in some cases I can regard it as a tiny house, but it's still, by class, it's a containerized building. It means you can ship it on a platform or truck and relocate it onto other location. The most important, you have to have a plot of land. It's a Passivhaus standard still has to be certified to be regarded as Passivhaus. It has to have all requirements fulfilled that set Passivhaus Institute from Building Smart, from Passivhaus International Association, that they also expressing their interest on BIM. So it means you need to design it well, prove it that it's meeting these requirements, and in order to prove them, you should run a simulation with a PHPP. PHPP is a Passivhaus plan package. So shortly about the project, it's a mainly research-oriented project. It came with ideas that we will work on the improvement of current containerized industry. And what we came up, it was a small project that successfully was implemented at the design stage, and later on we had the chance to get the quantitative of cost calculations so that we had we reached the stage that we could be able to build it and ship it on site. So we had the three parties involved: a client, which was who was my former boss, or let's say colleague, with whom we had dealt with a lot of projects on LEED certification, on passive house building, construction, energy efficiency projects. And my partner or colleague who have a prefabricated company, builder in Ankara, he did Prefabrik. He's experienced prefabricated builder, and together with whom I had the chance to develop this building. Of course, the client requirements are really vital. I will skip these pictures. It's the interior with that we were simply proposing at that time. Would potentially look this building. The use of the building is a vacational home outside of Ankara. Ankara is 6 million population city. It's crowded, and you would love to live outside and spend time on a remote location, but still that your building will cover your energy needs and be sustainable enough. So as a result of our research, we tried to apply for AEC Excellence Awards in 2016, and we were shortlisted to be finalists among 3 projects. We were, among the all worldwide projects, we had a chance to be shortlisted for 3, and so we were nominated for being a small project case. And client requirements. Client wanted to have the building. Before I will start, it's really important to follow client requirements. It doesn't matter what will be at the end, but if a client you will not meet his requirements, it will suck. In this way, he wanted to have relocatable building that will have a minimum impact on the nature and the ground. So you need to be careful about your foundation details, for which we simply used one detail from one company I cannot share currently, but it was a really unique solution that you simply dig into roads on the or hammer those roads onto the ground, and it will be regarded as a foundation or the piring details. So it should be cost efficient, it should be affordable. In the same time, he has, of course, user requirements like 1 bedroom, 1 living room with small kitchen, shower room, WC, and along with requirements from clients, there were requirements like road permissions. You need to relocate that building. You be able to relocate the building. The maximum width, maximum length, and height. The most important height. That was really tough to meet, especially taking into account that at that time Turkey was planning to enter or still willing to enter the European Union, and they had to follow European Union directives. So that part was also really difficult to consider, and so the building shaped according to that requirements. So I will go back to the history of containerized buildings very shortly. It's mainly used for construction sites as office building. There are many more cases, but still the most common case is emergency and disaster relief cases with a lot of shelters or construction site buildings. And from I chose one construction site exactly here on the lower side, together with Venesco, the client. There was a construction site, foreman's office. It's really leaky in a way. They are not so efficient in the energy codes. So it has to be improved. I had to go through some site analysis, site measurements, and before doing that, I had to go through the simple construction analysis, how the prefabricated construction works, since I had a chance to work in that field for many years, but still I had the chance to go deeper on the design phase, to get work in design department with my colleagues to find out how you could face those problems later on and how you could find a solution. So that's mainly, as you can see, I will go through simply. This is a structure of containerized building, standard containerized building that you can see. It consists of walls and panels. It can consist of, it can be insulated or without insulation, but in most of the cases, it should meet certain standards. There are a lot of problems in building envelope. It's not only normal buildings, but containerized buildings, and in most of the cases are leaky. They have a lot of thermal bridges. They have issues on the connections between two container units or even between panels and openings. So these kind of issues I was addressing on my master thesis. I performed blower door test, thermograph analysis, and energy simulation on site on exactly this building. As a result, you can see on the graph of these results that it mainly affects how, in spite that people saying or commonly know that on site installation it's always have problems, but on the other hand, the building that was assembled in a factory could minimize that, which in this picture you can see on the contrary. It means you should be careful about detailing, and when we talk about detailing, BIM method really helps to find out those. I mean, to foresee that potential issues. So that's how I performed improvements and see how it will affect on energy demand. As a result of some minor improvements, I had the chance to eliminate air leakage, but condensation, thermal breach, and all other factors were still remaining. If you're interested, I added here two links for my research paper publication about this findings and how could you improve them. So if you have time, you can read. So we tried to implement the first very economic version. It's a tiny house, really affordable. If you want interested, you can go to the link he did Prefab. He erected this building directly in a manufactory and shipped it on site. It's outside of Ankara and based on really simple materials. The interior furniture was bought by IKEA, and it's really affordable. But in order to work on green prefabricated, you should consider a lot of aspects, and those aspects should be not only time, but also the way you construct. So in that case, we follow this DFMA principle. So it's a design from manufacturing assembly. You should recycle some materials. You should work on DFMA stands for assembly efficiency, manufacturing efficiency. So actually, this approach were offered by Richard Kelly from Building Smart International to start a working group by Building Smart International. And this approach was also addressed by Building Smart Singapore during the competition, BIM competition in 2015. This I would really suggest you, if you are interested in this topic, please look through the FMA. What it brings, you will save time on site, you will save time on manufacturing, and of course waste reduction. Before I start, I will give you a simple, short introduction. What's a passive house? Passive house is really energy efficient, super energy efficient building based on 5 principles. It's thermal insulation, very good thermal envelope, certified windows and doors, airtight. First of all, you have to have adequate ventilation, passive ventilation, but still ventilation with heat recovery. Air tightness is a very important aspect, and thermal breach reduction. Both thermal breach and air tightness have a very huge impact on the energy demand. So before we go deeper in the design process of passive house, you should know how PHPP, the passive house plan package, works. It's mainly based on XML or like Excel sheet, but still it has steps that you have to follow. It actually makes it easy when you're using any BIM authoring tool that able to export ISC, and later on you can export quantity takeoffs. Together with a quantity takeoffs, you can simply fill, not you have to work a little on it, but fill those values onto your PHPP and run your simulation. Currently, Passive House Institute worked on or already released a first draft of or first demo version of Passive PH to BIM. So there is already existing plugin for Revit, for ArchiCAD, Allplan, all that known BIM authoring tools. You can directly try. Of course, it runs with bugs. They are trying to improve it. So, but the principle, if you understand the principle of working with PHPP, you should simply be able to run a simulation without the plugin. Another aspect that you have to follow and really be aware of, components. When you run your simulation, at least you know which. At the first point, you have to run run simulation was on generic components, and as soon as you go into detail, you know which components will be meeting your requirements, and you can find it on component database of Passivhaus Institute. So simple workflow. It's not BPMN workflow. I simply made up my mind map, let's say, or it's like brainstorming how it worked that time in 2015, 2014, on that time. What we did, the simple way of Revit massing. Revit was used for architectural floor planning, very simple way, but still you have to focus that you have your build wall connection mapped with right entities, classes, AEC wall. You have to give proper properties like is it external or load bearing file classes if it's already known, or if it's not, if your client requires, I mean, in that case, in our case, client required that it will be incombustible, it will be durable, it will be required that it has specific U values by what you come up with a simulation later on. But still, you should be aware that you always have to keep an eye that you follow this mapping rules. And we explored at that time. Nowadays, you can try with IFC4 reference view or design transfer view, but be careful. Not all softwares are supporting IFC4 right way, or not all softwares are certified. So you have to be careful with version of IFC. IFC2 is 3. It's commonly used, very widespread. The export is really, I mean, this format, the schema implemented by most of the softwares, and of course it has not so many entities that you would expect. In some cases that are really not working. You wish that you had more, and that's you have to make the custom settings. So we exported the IFC 2x3 to as a simple reference, and imported it back to Archicad, and created our structural framing structural model. Later on, we merged all this files in SolidBIM model checker, which helped us to go through issues. And in most of the cases, our issues were really not time consuming in a way. If you can, in spite it's a small project, it can be a big project, it still you can miss some points. And this model checking in general helps to oversee and eliminate those problems. So one more tool that I had to use, because daylighting, and this is a sustainable building, you have to focus on daylighting, and you also have to focus on lighting loads. So I worked with, I'm still working with Dialux, that you're able to import IFC files and directly run your simulation. You can directly implement all necessary standards that you would like to meet. You can directly run or install your lighting fixtures and simulate further scenarios. So for site analysis, I mean site planning, it was not in our case, because it's we are really not we were not dealing on with a site. Our goal was to deliver a building, and the site was on the client part. So but still we have sites. We made a drone survey of the site at times, and it was really interesting to find out that in order to reach that area, you have to have a convoy, you have to have special permission on the road, and you even in some cases, since we were driving outside of Ankara, it has to go on highway, and it has to be delivered on night basis, so at night. So I mentioned that PHPP is based on Excel, so it means we have to export. To save the time, you can simply export once and from the the quantities from IFC file. It really helps. And but important aspects that you have to follow. I'm again talking about this is indirect way of expressing your workflow. I know potentially how the climate would affecting my building, but still, this building potentially could be relocated to other location. So you should always run all necessary simulations again. And you, of course, you should give an implementation that this specific site that we have seen, you can see it on the right picture. It has it was very huge plot. There are a lot of different complexes and the buildings like tennis courts. There's a hotel, abandoned hotel, and my client was supposed to get this small plot of land from his friend, and as far as I remember, it's still in progress. And the area is really hilly, but it's really real remote and difficult to reach. So the costs for transportation really affects building in general, building costs. So the site was also before we started, we already knew that which I ran the simulation for PV analysis, so you could simply know on how big your PV panel, how many panels you need to meet your requirements, energy lots, and when it would pay it back. So feasibility analysis has been conducted, and it says that we have 6 years to cover our building. So this is a building architectural export, simple containerized building. Based on I-joist, TGI joist was insulation in between butt insulation, mineral wool, or we also checked the option to have a cellulose, blown cellulose insulation. But the mineral wool was more cost effective, and it helped. It's also non-combustible. It's not. It's the fire rating was better than cellulose. And yeah, so we also had a chance to map all these requirements directly. I mean, from fire protection requirements directly on the building, and run it on a model checker, so it was we were on the safer side. The building has main entrance as a big, let's say, terrace door, and even with a cost calculation for estimates for RFPs, I mean the request for proposal from window manufacturers, we were able to simply export once our from the model, generic model, and request a quotation for that specific. It really helped because there you can directly find which model, which object you would like to have, and your U values, and potentially G values for the window. So this building has a Passivhaus certified window from Rehau. It should be Passivhaus certified, means it costs already 30% from your building. I will not tell exactly the price. I will at the end I will show you a breakdown, but it was surprisingly expensive. So whenever you consider working on Passivhaus, please run one simulation or in the principles of Passivhaus. On the south side, you should put more windows, the bigger, brighter windows, but still be aware that you should later on install overhangs or jalousies that be able to protect you from overheating, that's a really big problem. I'm living in a passive house building. I mean, and it's not that time. It was not designed that overheating will be so increasing by time. So energy loads affecting cooling loads as well. So we have two more main rooms. One is room 3, like living room, and other was bedroom. Daylight analysis, simple lighting analysis was really easy and went with one click from the IFC export. So the most important structural detailing, it really we had to work on the option where two different materials were considered. First one, steel construction, since the manufacturer we're working with, he's building a lot of different kind of prefabricated buildings, like hangars, pre-engineered buildings, panelized buildings, and also light gauge steel frame mill buildings, which is not commonly used in Germany, but very commonly used in Turkey and US. So that was the first option, but we had a big problem with thermal bridges, which we had to overcome. Since if you're using steel framing, you should implement thermal breaks, which really cost a lot. If you should put a thermal break on each post and beams and columns, it will really affect a lot. So additional simulation. And other point, we had to work on timber, which was easily implemented, but not common in Turkey. It's common in Europe, in most of the cases in Canada or in Norway and Scandinavian, but in Germany it started recently being a common thing to implement buildings with a timber frame. I'm a volunteer in Fire Brigade. I still have a lot of suspicions about case when or scenario that this building will burn down. But in order to do that, in order to be sure that you will meet your fire protection requirements, you need to implement those protective measures, like using proper insulation, and of course inner area should be also covered with non-combustible materials. In that case, we used or we have implemented gypsum board, fire-rated gypsum board that was simply in 2 layers used from the inner part. So of course, you should also be aware that the exterior cladding should be also non-combustible. In that case, we used that simple fiber cement panel that looked like timber, which also saved us a lot of money, since the timber, you can of course find recyclable or a timber that was already previously used. In that case, it might save. But still, if you're working with a manufacturer in the construction and not self-building, then you should simply work with whatever you have on market. So TGI joist, I-joist was implemented on the columns and beams, and rim joist we applied timber material, so that. But the other point, if you are working with I-joist as a TGI joist, you should be aware that you should you have to follow or be aware that might be a lateral loads, and to cope with vertical loads, you should use OSB plates. I mean, your OSB sheeting on both on one inner part and MDF on the outer part, or in some climates you can go use OSB on both sides. OSB oriented frame board, it helped to bind, so you have to use bracing. So we used OSB as for two purposes. It's as a cover for our insulation, and it also have load-bearing purpose. In addition to that, as it can maybe seen on the picture, there is also inner part. We chose steel profiles instead of timber. Steel profiles is more strengthened and it's flexible in a way that you can find or you can use a cold form profiles. So that's what we're talking about. Inner part for drywall, for toilet and shower room. We mechanical room used the simple timber, not timber, steel structures. So that length all quantities were easily exported. So we were able to calculate all that materials, how much you need material and what will be quantities at the end. So the most important to run thermal bridge analysis, you should know that thermal bridge free construction will meet Passivhaus requirements. We need to export fenestration doors in that case separate, and windows quantities, which window with which properties, and yeah, that was already clear at that moment. We had the first moment we had the generic, and as soon as we got the price proposal, we knew that that specific profile, Passivhaus certified profile, was meeting our expectation, and it's even more by price. It would really be feasible to use that, so we directly found downloaded the profiles directly as the BIM objects from a manufacturer, and we simply implemented them on the building. So the important aspect that I said, IFC wall, if IFC column, all IFC beam, all this IFC roof and flap, so you have to match them. IFC window. And the first, you have to put a list of your requirements. I mean, you will definitely need the walls, roof, and windows in most of the cases, and you simply have to go through them. If your authoring tool is not supporting it, then you should try to map it somehow. In that case, it consumes a lot of time. So beams and quantities, sorry, oops. So at the end, you can merge them and export, and you know your quantities and if that really needed in your model, and how you would cope up with clashes. So simply what we had, and the client was planning to find his, he was willing to use his, he was planning to use his resources to support and to reduce the prices for installation of insulation, gypsum boards, and airtight membranes that we were targeting to get sponsorship and to get in a constant reduction of prices. So that's values we simply exported from IFC. And at the end, when I worked on the price calculation, windows, as I said, we had the price. I can simply say that time it was around, I guess it was 8 or 9,000. So it means pretty, sorry, 6,000 euros plus all other costs, additional costs. So it's really cost. The biggest part that takes the total cost. Heat recovery ventilation is that time was we were planning to import it from Germany. It's manufacturers, and most of the manufacturers are based in Germany. And of course, PV system, you can make a comparison with Chinese manufacturers or local, but in back 2014, you don't have so many alternatives, or at least you didn't have the alternatives. And our tightness layer, we were planning to use Proclima materials, and we got already a quotation and offer from the Proclima, and it was of course based on 2014, and so far it's everything changed. So at the end, we ended up in the price of 64,000. It's not included. It's not included the inner furniture. So that part of ventilation, you should install sanitary ware. That was not in the scope of our project. Sanitary ware, toilets, installation, the showers were on client part. So I have, I guess, exactly 15 minutes, and we can have a question session.
Okay, perfect. Thank you very much, Mirbek. Let's see, I'll connect the cam so that you can see me. Hello, everybody. Thanks for watching. Thank you very much, Mirbek. That was a very interesting case, very detailed with costs and everything. I think it's useful because it's a part of the project that sometimes we don't get to see. So it's also interesting to know, obviously, an approximate cost for this kind of projects. I do have a couple of questions here. Give me a sec. Very good. So we have Khalid asking, how can the prefab help construction professionals in Africa, considering that the companies are not easily found or set up and the climate is tropical? So sometimes there's the need of air conditioning due to high temperatures. I don't know if you have any previous experience of, if you heard also of passive house designs in Africa, maybe you can share a bit with us.
Yeah, sure. Passive house standard works not only for cold climates, but also for tropical climates. You can simply go to Passive House International page or Passive House Institute, and there are 2 articles exactly for hot, arid, and hot, humid climates. The first addresses projects in exactly one project was in Dubai, and the second one was, I guess, in South China. And both of them are quite good. Had issues on cooling loads rather than heating. In that case, you have to follow those measures, like to have overhangs or to have proper shading devices. And in some cases, you will definitely need dehumidification if it's a humid climate, and you should most probably use active cooling.
But the active cooling, you would be able to connect with renewable energy. I'm talking about photovoltaics, not solar hot water. I'm talking about photovoltaics that really covers your daily needs for cooling. But another aspect, you said that the projects in Africa, yeah, as you currently back then China was not active in Africa. Currently China is really targeting that market, and they have a big market, and they're trying to support these companies that are working in African region. But in other aspects, if you are designing a building in the other country, you can still relocate it. It doesn't matter if you are based in Turkey or in Germany. Of course, in some cases it's the transportation cost, but I remember the case that the building was manufactured in China and delivered to Canada. And I had the chance to participate on the Solar Decathlon project. It's a sustainable prefabricated competition for students and for that specific area of manufacturing and prefabricated manufacturing and assembly. It's annually run in the US or also even in Europe. Recently they started in Europe, and that was with China. These projects are really open for everyone. You can go onto the site, Solar Decathlon projects, and you can benefit from their research. They're working on that field. As far as I remember, in Africa, there are companies that indeed, I had the chance to work in that company. I will not name them, but you manufacture on site really rare in Africa. There are a lot of issues with building materials. And sorry to tell, in some cases you need to find highly qualified mancraft who would assemble that. And I'm not talking about Passivhaus experts that should run simulation or run analysis, blow dot tests. So it's quite tricky, and it's easier to implement directly at the factory building and see if this building will meet your needs already at the factory before it will be shipped. As soon as you did it, you can ship on trucks on the land, or in some cases over sea transportation with freight containers, and that's there are a lot of different ways. But companies, of course, I agree with that. It's difficult to find a proper company that's really reliable.
Okay.
I hope I did
I
answer
understand.
your question. But the Passivhaus works in hot, arid and hot, humid climates. The most important, you don't have to be to use dry triple glazed windows, but it has to be airtight. Airtight is really even the most important aspect, because you will be cooling the building, and the cooled air should remain in the building. And overheating is a big risk, so you should focus on that.
Okay, very good. Thank you, Mirbek. So we'll go to another question from Zoran, and the question is, which software was used for modeling, not for energy analysis? Zoran says.
Not for energy analysis.
Which software was used for modeling? Yes.
For modeling, yeah. For modeling, we used that time, as far as I remember, ArchiCAD. I don't remember even which version was that. It was really long ago, 6 years ago. But ArchiCAD was quite good, and openBIM and Revit was also good to use for architectural simple use. but it was tricky to implement mapping in Revit. It was really tough job. You had to implement to install. That time they didn't have integrated. That you had to find out in depository for a plugin, for IFC plugin, and then you had to match those families, those classes with your desired entity or class. If you need to, if you have a common wall, you have to use the IFC wall, and then in most of the cases, you also have to create additional properties that were not by standard or by default foreseen. So that was really tricky. But still, it was easy to export IFC at the end. I mean, it's not matter of IFC. IFC can everything. It's a matter of user. If you're an advanced user, you can do that. But still, if you're at the very beginning of using IFC and you don't know it, you should still dig into Building Smart technical site and find this IFC structure. Sorry, it's a IFC. Official publication of IFC. You can find the structure. You can find. Hold on a second. I will show you. Maybe I will directly show you the website, so you can profit from that part. Here you are. You see my screen?
Yes.
So yeah, so I'm talking about this site. You go, it's for IFC4, but there's still, and when you go to technical side, you will find the IFC for 2 3, but we will not go back now. We will focus to the future IFC4, and it has alphabetical listings, or you can directly go to domain-specific schemas, and from domain-specific schemas you have you can go through the entities, what entities are. You can simply go to index. It's also helpful. You can simply let's simple Google search for IFC wall, and by search you will find this element cases, and you can go through all these aspects, all these items, indexes. But domain specific, it really helps if you to know what electrical parts or HVAC parts are already in the schema and what you can do. So in addition, I would suggest to know that Building Smart has additional standards. I mean, other standards like IADM, Information Delivery Manual, and MVDs. MVD, I can give you just a small analogy. IFC is a cake. MVD is a slice of cake or specific one specific part of cake, and IDM is a recipe. IDM describes how you will bake that cake, what's the use case in general. It can be brownie, it can be apple pie, it can be other case, and how to bake it, and what are the ingredients. And those ingredients are your exchange requirements. And how to bake, you can of course have a video introduction, so analogy can be a process map. The important points, you have to know your processes, you have to know your exchange requirements. You being as an energy or a sustainability consultant, I need from architect all specific things, like I need areas, I mean floor areas, rooms, or simply spaces with volumes in most of the cases for blower tests or for calculations for the Lüftung. HVAC, and I need surfaces for fenestration, windows orientation. I need U values, but I don't need U values. I need lambda values, the thermal conductivity of the material. Then I can simply calculate my U values. and I need to know the usage. So I have my own specific requirements from architect or from other engineer, but that's a point what we have. That's important
very
have
good.
to have a processes. So
Understood. Yes, there's another one. Muhammad asks, are you aware of any LEED certified project which was prefabricated? I'll repeat. Are you aware of any LEED certified project which was prefabricated?
Yeah, I got it.
Okay.
I'm also doing LEED certification for buildings. So
Okay.
you have to be careful talking about LEED. There are three different more different certifications, like for new construction, for LEED for homes, or currently changed for LEED for residential. It's LEED for homes means up to 3 stories, and it's a residential, then you should apply for LEED for homes. If you have bigger than 3 and there are the square meters, then you apply for new construction. For existing buildings, of course, there are existing LEED for OEM, operation management, and there are also LEED for cities as well. And so but yes, there are buildings certified for prefabricated. If you wanted to say about prefabrication, it shouldn't be necessarily containerized building. Prefabrication means you can prefab your building parts and ship to the site and assemble it. You can have LGSF, light gauge steel framing buildings, which are really common in the US. You can apply for LEED certification if you're using specific the VOC free materials. You plan that way that your energy demand will be better than baseline case. That helps to simply run simulation. You can do your building with IFC, and if that energy simulation tool supports it, you can import it and run 2 cases, one baseline according to ASHRAE standard, and later on improve the building and run second time and see what is the percentage of improvements affecting on your demand. And according to that, you will achieve your LEED certified, or LEED, silver, gold, or platinum level. But LEED is simply criteria. Passivhaus is a standard. So it means if I build a Passivhaus, my prefabricated building according to Passivhaus, and it's really Passivhaus certified components, and Passivhaus Institute already approves it, I can apply to LEED. Some additional aspects should be that you should focus on also not only on building itself, but on site. So sustainable site should be also credited for that. Transportation aspects, social, economical, ecological aspects. So this all plays a role in LEED certification. Yes, there are a lot of examples.
Thank you very much.
We don't have enough time.
Sorry. Sorry, guys. We are really on the last minute, so we have to finish the session. If anybody else has another question, feel free to contact us afterwards, okay? So you'll receive an email now after the presentation. Feel free to reach us. If you have any questions also for Mirbek, you have their is LinkedIn, so just give us a shout out. Thank you very much, Mirbek, for your participation today. And for everybody else out there, just stay tuned for our next masterclasses, okay? Everybody have a good afternoon.
Thank you so much. Thank you. Say hi to David.
Okay. Bye-bye, everybody.
Okay. Bye.